Hi, AP Stats. We're going to continue talking about relationships between two categorical variables. And so pretty much we've been dealing with quantitative data for most of this chapter. We're going to flip back and talk about categorical variables. A lot of you probably could be able to figure this out on your own, but we're just going to talk about it a little bit. There's some interesting stuff that comes up. So two-way table, it describes two categorical variables. Okay, marginal distributions are the distributions of categorical variable alone rather than looking at the total. Okay, so you just kind of break up the table and just look at one category. No single graph portrays the form of the relationship between categorical variables. No single measure summarizes the strength of the association between two categorical variables. But we will discuss this much later in like chapter 14 next semester. All right, example 24. The following table is Census Bureau data describing the age and gender of college students in thousands of persons. Note, row and column totals are not exact due to some rounding error. These are the two-way tables to answer the following questions. Okay, what percent of college students are 18 to 24? Okay, so for this, again, we look at the total for 18 to 24 over here, divide by the grand total. Okay, so we've got 10,365 over 16,639. Okay, so grab your calculator and you can do these along with me. So these are 0.623. Ask for percent, so 62.3%. All right, so I'll erase that. Okay, and what percent of college students are female? Okay, and then what percent are male? So percent that are female, look at that. We're going to look at the total for female out of the grand total. So female is going to be 9,321 divided by the grand total of 16,639. Okay, so that comes out to 0.56 or 56%. The males, the total for them, 7,317 divided by 16,639. So we get 0.44, 44%. Okay. So what percent of 18 to 24-year-old college students are female? Okay, so for this, we're looking at what percent of 18 to 24-year-old college students and then are female. So our total is going to be the 18 to 24-year-olds. We want to look at this. Of these students, okay, just looking at those students, now what percent are female? Okay, so of those, 5,668 are female out of the total 10,365 who are 18 to 24. Okay, so that, sorry. That comes out to be 0.547. Okay, 54.7%. The hard thing about these is just making sure you're dividing by the correct number. That's definitely the hardest part. Usually most students always get the numerator right. Dividing by the correct number is usually the hardest part. Okay, what percent of 18 to 24-year-olds now are male? So we still have the same denominator. We're still dealing with the 18 to 24-year-olds. And now we just want to know how many of those are male. So in this row, the males are right here, 4,697. Okay, so go ahead and calculate that. It's obviously the opposite of part C, so we get 0.453, 45.3%. What percent of female college students are 25 to 34 years old? So now we're going to just look at, let me erase this up here. We're going to look at just the female college students. So here, females, this is what we're looking at. of the females now, how many or what percent are 25 to 34? So 25 to 34, we have 1904. Divide by the percent that are female, so our total that are female, 9,321. So 1904 over that, 0.204, so about 20%. Okay, so I'm answering them as percent because that's what it asked for. But okay, what percent of female college students are 35 or older? So our denominator, we're still dealing with just females, is the same, and then our 34 and older is 1660. Okay, so that gives us 0.178, 17.8%. All right, and then for G, what percent, now we're going to switch, of male college students are 25 to 34. So we look at our table. Now we're not just dealing with the females, we're looking at males. Okay. So 25 to 34, we have 1589. Okay, 25 to 34 males, and the total is 7317. So when we calculate that, 0.217, 21.7%. Okay, so the trick to these, making sure you're dividing by the correct number. That's always the trick to succeeding at these. All right, flip the page with me. We're going to finish talking about one thing that has to do, blow this up a little bit, with categorical variable, two categorical variables, or two-way tables. And it's called Simpson's paradox. Okay, so it's just an interesting little thing that comes up here. And so we're looking at an association or comparison that holds for all of, okay, so it holds for all of several groups, but can reverse direction when the data are combined. Okay, to form a single group. So we're going to look at this. And some students sometimes ask me if I made up this data. I did not make up this data. It's from a textbook, so I don't think they made it up. Most data is just out there and we just use it. Okay, so example 25. Accident victims are sometimes taken by helicopter from the accident scene to a hospital. Compare the victims who die with helicopter evacuation with the victims who had usual transportation to the hospital by road. Okay, so helicopter, road, victim died, victim survived. Okay, something to think about when you end up having to be transported in a helicopter. What do you know about your injuries? They're going to be more severe, okay, versus then taking someone by ambulance to the hospital. Okay, they call a helicopter when it's severe. So that's something to consider when we analyze this. So part A, find the percent of helicopter patients who survived. Find the percent of patients who survived when they were transported by road. So we're looking at survived, okay, so people who lived in both of these. And we are going to look at the helicopter. Okay, and then we will look at they were transported by road. Okay, patients who survived. So victims who survived in the helicopter, 136 out of 200. Okay, so that gives us, we'll just look at 68%. The road victims who survived, 840 out of 1,100. Okay, so 76.4%. So we're going to keep a little tally over here. Who was lower? Okay, between these two, which one was lower? The helicopter. Okay, we're just going to keep track. Okay, helicopter had lower survival rate. Okay, explain this. Again, usually there are more severe injuries transported by helicopters, so because they're more severe, they may not have as high of a survival rate. Does that mean that actually transporting them in a helicopter causes them to not survive? No. Okay, so it's the injuries. So there are more severe injuries for victims who are transported by helicopter than on the road. Okay, so here are the same data, but we're broken down by seriousness of the accident. So we have serious accidents, less serious accidents. Okay, so notice our totals are the same. Helicopter, there's still a total of 200. Road, there's still a total of 1,100 when we're looking at our totals down here, okay, compared to the totals up and above. We're going to look at, again, we're still looking at survive. So what percent of road patients survived, and what percent of helicopter patients survived when we look at serious accidents. Okay, so we're looking at just the serious side. So we're going to look at, again, helicopter, and then the road. We're looking at survival. So in the serious accidents, there was 52 out of 100, so 52%. The road, there are survived is 40 out of 100, so 40%. Okay, keeping our track. Which one is lower? Yeah, the road is lower, okay, 40% compared to 52%. So over here, we have the road is lower. And then when we look at less serious accidents, when the other side of the graph, table, and we break it down, helicopter, road, survived, again, we're looking at, we're looking at survival for the helicopter and road. So helicopter is 84 out of 100, so 84%. And the road is 8,000 out of 1,000, so we get 80%. So which percent is lower? The road. Okay, so when we broke it down by seriousness of accidents, the road had a lower survival rate, but when we had it totaled up together, the helicopter had a lower survival rate. Okay, so it's definitely one of those weird things. It's called Simpson's paradox. I didn't change the data to make it work like this. It's just sometimes this happens. When you break it down into the totals and you break it down into categories, the response can reverse. Okay, cool thing. Okay. End of chapter 1, things you should know. Make sure you can do all of these and you'll be ready for the test.